Hello and welcome to The Sleepy Scientist. It is lovely to have you here tonight. Before we begin, I would love to know, where in the world are you listening from this evening? Perhaps you're settling into a calm bedroom as the night draws in, or resting somewhere quiet after a long day. Maybe you're tucked into a corner of the house with a dim lamp beside you, or simply lying down with your headphones on as you unwind. Wherever you are, I hope you feel safe, relaxed, and ready to let your mind wander gently. If you enjoy these calm explorations and would like to hear more, a like and subscribe truly helps this little channel continue drifting along. And to those of you who are already subscribed, thank you. Your support means more than you might realize. If you would like to stay up to date, you're welcome to tap the notifications bell so you never miss a new sleepy science journey. Now, tonight's topic comes with a small warning. I will do my best not to make it so interesting that it keeps you awake, though if it does, at least you will drift through the night with a clearer sense of how your mind quietly constructs the world around you. A fair trade for a little extra thinking before sleep. So, shall we begin? Is reality actually real? Or is the world you experience shaped by the brain in ways you rarely notice? The world you move through every day feels familiar and straightforward. You see objects, hear sounds, feel textures, and the brain presents all of this as a seamless picture of what is. A chair looks like a chair. A street looks like a street. Everything appears stable and consistent. But the moment scientists began examining how the brain processes information and how the physical world behaves beneath the surface, things became far less certain. Perception turned out to be an active construction, not a passive recording. The senses gather fragments, and the brain fills in the rest, smoothing over gaps so well that you rarely notice they were ever there. And on the physical side, the deeper you look into matter and energy, the more the familiar world begins to blur around the edges. It is not that reality is false, it is that reality is layered, filtered, interpreted, and sometimes delightfully strange. In this video, we will drift gently through these layers. There is no pressure to remember names or theories. There's no need to grasp every detail. We will move slowly, one idea at a time, exploring how perception works, how the brain creates meaning, how physics challenges intuition, and why the world feels solid even when its foundations are anything but. So make yourself comfortable, close your eyes if you wish, and let us explore a question that sits quietly beneath every moment of your life. If the mind shapes so much of what you experience, then what is it that makes reality feel real at all? When people talk about reality, it often sounds like the simplest concept in the world. Reality is what is right in front of you, the things you can point to, the things you can touch, the things that stay put even when you turn your back. It feels so obvious that it barely seems worth defining. Yet the moment you try to explain what reality actually is, the ground shifts a little, as though the idea is not quite as firm as it first appeared. Everyday reality is built on what your senses tell you. You see a table, so the table exists. You hear a sound, so something must have caused it. You feel the ground beneath your feet, so the ground must be real. This version of reality is practical. It is reliable enough to let you make breakfast, open doors, cross streets, and carry on with your life without needing to question the nature of what you are interacting with. This kind of reality is shared, predictable, and familiar. But scientific reality is sometimes a very different story. Once you step into the world of measurement, experiment, and theory, the picture becomes more complicated. The table that seems solid is mostly empty space. The ground that feels unmoving is floating on shifting plates. Even time, something that feels like a steady flow, behaves differently depending on speed and gravity. Scientific reality is not the world as it feels, but the world as it behaves under close examination. It does not always match intuition, and it does not always behave politely. This contrast between everyday experience and scientific description raises an interesting point. Reality might not be a single, straightforward thing. It might depend on the framework you're using. What counts as real to a physicist may look very different to what counts as real for a psychologist, or for someone simply going about daily life. A physicist describes fields and particles. A psychologist describes perception and interpretation. Both are grounded in evidence. Both describe genuine features of the world. Yet they do not always overlap neatly. And then there is the philosophical angle, which adds yet another layer. Some thinkers argue that reality is whatever exists independently of the mind. Others claim that reality must include the mind, because experience is impossible without someone experiencing it. Still others suggest that reality is not a single category at all, but a network of relationships, objects, perceptions, meanings, and shared understandings all woven together. This might sound abstract, but it becomes clearer with everyday examples. Take colour. You see a red apple and it feels natural to say the apple is red because redness is simply part of the apple. But scientifically, the apple is reflecting certain wavelengths of light. Those wavelengths do not contain colour on their own. The sensation of red is something the brain creates. So is the apple red? In one sense, yes. In another sense, no. The answer depends entirely on which version of reality you're talking about. Or consider sound. A ringing bell sends vibrations through the air, but a vibration is not a sound until a brain interprets it as one. Without an ear and a mind to process the vibration, there is movement in the air but not the experience of hearing. So is the sound real, or is the vibration the real thing? Again, it depends on what you mean by real. These examples reveal something subtle. Reality is often a combination of what exists independently and what the mind contributes. The world supplies the raw ingredients. The brain turns those ingredients into a usable version of reality. This does not mean the world is an illusion. It means the world you experience is shaped, filtered, and interpreted. Some aspects of reality depend on agreement as well. Think of time zones, borders, money, or even the meanings of words. None of these exist in nature. They are constructs created by humans and kept alive through shared understanding. Yet they have real effects. They shape lives, decisions, and entire societies. They are not physical objects, but they are undeniably part of the reality people live in every day. This idea helps explain why defining reality is so challenging. Reality is not only the physical world, and it is not only the world inside your mind. It is a combination of both, plus the systems of meaning humans have collected over thousands of years. What is real can depend on how it is measured, who is experiencing it, and what context it appears in. When scientists talk about reality, they often use the word to describe the universe as it exists whether or not anyone is looking. The patterns and laws that hold true even in the absence of an observer. But your personal experience of reality is different. It is immediate, sensory, and shaped by attention, memory, and expectation. These two versions of reality often overlap, but they are not identical. A helpful way to think about it is to imagine a map. The physical world is the terrain. Your mind builds the map that lets you navigate it. The map is not the terrain, But without the map, the terrain would be too complex to manage moment to moment. The mind simplifies, highlights the useful parts, and smooths out the rest. The result is a version of reality that works beautifully, even if it leaves out a great deal of detail. Understanding this distinction is not meant to unsettle you. Instead, it offers a clearer picture of how remarkable perception truly is. You're not passively observing the world. You're constantly constructing it, updating it, correcting it, and filling in the blanks. And you do this so seamlessly that it feels effortless. When you begin to explore what reality means from different angles, you start to see why the concept is much richer than it appears. It includes the physical world, the mental world, and the shared world humans create together. It includes things that can be measured and things that can only be felt. It includes the stable laws of nature and the personal interpretations added by every individual mind. What this reveals is that reality is not something you simply encounter. It is something you participate in. It is shaped by observations, choices, meanings, and interactions. Asking what reality truly is becomes less about uncovering a single answer and more about understanding how all these layers combine to create the world you navigate each day. And so, as you move forward, a quiet, lingering idea begins to take shape. Reality might not be a single, fixed thing waiting to be discovered. It may be a collection of overlapping truths, each revealing something different about what it means to exist. When you open your eyes in the morning, it feels as though the world simply appears. Colours, shapes, and objects seem to flow effortlessly into view, as if your senses were tiny windows showing you reality exactly as it is. But the brain is not a camera, and the eyes are not lenses recording a perfect stream of information. What you experience each moment is not the world itself, but a version your brain constructs using signals, memories, guesses, and a fair amount of creative interpretation. The brain receives an enormous amount of sensory data, but that data is messy, incomplete, and often ambiguous. Light enters your eyes in scattered fragments. Sound arrives as waves with no instructions attached. Touch gives small pieces of information about pressure or texture. None of this arrives with labels or explanations. The brain has to interpret it all, combine thousands of tiny signals, and decide what they mean. In a way, the brain is constantly solving a puzzle without ever seeing the full picture. Because the incoming information is so limited, the brain fills in the gaps. If you glance at an object partly hidden behind something else, your brain completes the missing parts automatically. If you hear someone speaking in a noisy room, your mind uses context to reconstruct the words. Most of the time, this filling-in process works so well that you have no idea it is happening. You simply feel as though you are seeing the world as it is, rather than a carefully assembled interpretation. Illusions reveal this process more clearly than anything else. A simple optical illusion can make two identical lines appear different in length, or cause a still image to seem as though it is moving. Your brain is not malfunctioning when this happens. It is doing exactly what it always does, trying to make the best possible guess based on limited information. Illusions are not tricking the brain so much as exposing the shortcuts it takes when constructing perception. One of the most famous examples is the way the brain interprets shadows and lighting. If two squares on a checkerboard receive different amounts of light, the brain adjusts their appearance so they seem more consistent with the expected pattern. Even when you know the squares are the same shade, they continue to look different because the brain insists on correcting the image for you. It is trying to be helpful. It just happens to be wrong in that specific situation. But visual illusions are only part of the story. Auditory illusions can cause you to hear sounds that are not present. In a noisy environment, the brain predicts what someone is likely saying, and sometimes the prediction overrides the actual sound. Touch can be fooled too. A classic example is when your arm falls asleep and tingles so intensely that it feels as though someone else is touching you. The nerves are sending confused signals, and the brain does its best to interpret them, even if the interpretation does not match the real cause. All of this leads to an important idea. You do not directly experience reality at all. You experience the brain's model of reality. The world you perceive is built using the information available, but it is still a construction. The brain is constantly updating it, correcting it, predicting what will happen next, and smoothing out anything that does not fit. This is not a flaw. It is the only way perception could possibly work. The brain evolved to create a useful version of reality, not a perfect one. Expectations play a larger role in perception than most people realize. If you expect to see something, your brain becomes more likely to interpret ambiguous information as matching that expectation. This is why you might think you see your phone light up out the corner of your eye, only to discover that nothing happened. The brain predicted the event, so it briefly created the perception of it. Or consider walking into a room and thinking you hear someone say your name, only to realize the sounds were unrelated. Once again, the brain was searching for patterns it expected. Even taste and smell rely heavily on expectation. A food that looks sweet may taste sweeter purely because your brain predicted it would. A scent may seem stronger if you anticipate it. In experiments where identical foods are dyed different colors, people often report entirely different flavors, even though there is no physical difference. The expectation shapes the experience. These examples show how much power the brain holds in determining what you perceive as real. It is constantly predicting, correcting, and adjusting the model of the world it presents to you. Sometimes this leads to mistakes, but most of the time it allows you to navigate life with remarkable ease. The brain's guesswork is so fast and so effective that you rarely stop to question it. Yet this efficiency comes at a cost. The senses are surprisingly unreliable when examined closely. They work well in familiar situations, but can struggle with unusual ones. Your vision can miss large changes in a scene if you're not paying attention, a phenomenon known as inattentional blindness. Your hearing can misinterpret sounds if the context is unclear. Even touch can be misleading when signals arrive out of order, or when temperature tricks the receptors. Still, these limitations do not mean the senses are broken. They simply show that perception is less like a photograph and more like a constantly updated sketch. The brain aims for coherence, not accuracy. Its goal is to create a world that makes sense, fits your expectations, and supports your ability to function. A perfectly accurate representation of reality would require far more information than the senses can gather, and far more processing than the brain could manage. The idea that the brain constructs your world might sound unsettling at first, but it can also be comforting. It means perception is adaptable. It means you do not require perfect information to live effectively. It means the brain works endlessly to give you a stable experience in an ever-changing environment. When you walk into a room, you do not need to analyze every surface. The brain does the heavy lifting, presenting a ready-made version of what you need to know. There is also something quietly fascinating about the idea that each person experiences a slightly different reality. No two brains interpret the world in exactly the same way. Differences in attention, memory, emotion, and expectation can lead people to perceive the same event differently. None of these versions are wrong. They are simply different interpretations of the available information. Understanding how the brain builds a world helps explain why reality can feel so steady while being so flexible underneath. It reveals how perception can be both incredibly reliable and occasionally misleading. It shows why illusions work, why expectations matter, and why your experience of the world feels effortless, even though the brain is performing countless operations behind the scenes. And perhaps most of all, it highlights something remarkable about being human. Your perception is not a passive process. It is an active, creative one. Your brain is constantly constructing a world that feels coherent and meaningful, stitching together fragments of information into the experience you call reality. Once you see that perception is a construction rather than a direct recording, the world begins to feel a little more interesting, a little more curious, a little more open to interpretation. And in that small shift, the nature of reality itself becomes just a bit more intriguing. When you press your hand against a wall, it feels solid and unmoving. The floor beneath your feet feels firm. A chair feels sturdy enough to support your weight without question. Everyday life is built on the assumption that the physical world is made of solid, continuous material. Yet the moment you zoom in far enough, that sense of solidity begins to dissolve. What appears unshakable at the human scale turns out to be composed of vast amounts of empty space, held together by forces you never directly feel but rely on constantly. Matter, as familiar as it seems, is mostly nothing. If an atom were expanded to the size of a large stadium, the nucleus would sit at the center like a small grain of sand. The electrons would be tiny points moving somewhere near the outer edges, and the rest of the structure would be empty. Not empty in the everyday sense, but empty of physical substance. The overwhelming majority of what feels solid is space shaped by forces. This raises a natural question. If matter is so empty, why does anything feel solid at all? Why does your hand stop when it reaches the wall instead of passing straight through? The answer lies not in the atoms themselves, but in the interactions between them. Solidity is not an inherent property of matter. It is a result of the way electromagnetic forces behave when the electrons in your hand encounter the electrons in the wall. Both sets of electrons resist being pushed into the same region. They repel each other strongly, and that repulsion is what creates the sensation of touch. In other words, what you perceive as solidity is really a gentle standoff between electric charges. The wall is not solid in the way intuition suggests. It is stable because the forces inside matter are strong enough to hold everything in place. You never feel the emptiness. You feel the resistance of one set of particles pushing back against another. It can be surprisingly difficult to accept this idea, not because it is complicated, but because it contradicts a lifetime of instinct. You have touched things every day since childhood. You have leaned on walls, picked up objects, climbed stairs, and trusted the physical world without hesitation. The mind becomes so accustomed to the experience that it is easy to forget that sensations are created by interactions rather than by solid material. The deeper layers of matter make this even more fascinating. Atoms are not the smallest building blocks. They are composed of electrons, protons, and neutrons. Those particles, in turn, are made of even smaller components. And beneath all of that, what we call particles behave more like excitations of underlying fields. Instead of tiny marbles bouncing around inside matter, physics describes a world where everything arises from fields spread throughout space. A field can be thought of as something that exists everywhere, even in places that appear empty. When a field is excited in a particular way, it can behave like a particle. For example, the electron you read about in textbooks is not a small object with a fixed shape. It is an excitation of the electron field. The same is true for quarks, which make up protons and neutrons. The physical world on a fundamental level is made of fields that ripple, oscillate, and interact. This idea has a strange beauty to it. The objects you interact with every day are stable only because the underlying fields organize themselves into patterns that are consistent over time. The chair does not crumble beneath you, because the forces between its atoms create a structure strong enough to support you. The floor holds your weight because the atoms within it resist being pushed closer together. Solidity, strength, and structure arise from the collective behaviour of countless tiny interactions. This framework also explains why matter can be both incredibly stable and remarkably dynamic. The atoms in your body, for instance, are constantly vibrating. Electrons move through probability clouds rather than fixed paths. Quantum fields fluctuate even in what we call empty space. Despite this constant activity, the stability of matter is remarkable. A small handful of simple rules creates a world that feels rich and varied. There is something quietly amusing about the thought that you walk around on a planet made almost entirely of empty space, yet never fall through it. The idea seems absurd until you remember that the forces holding matter together are extraordinarily effective at maintaining structure. You could jump on the ground 1,000 times and never sense the emptiness beneath your feet. The repulsion between electrons is more than enough to keep the world feeling solid. Even the concept of weight becomes more interesting when viewed through this lens. When you stand, the force you think of as your weight is really the floor pushing upward on you. Gravity pulls you downward, but the floor reacts by pushing back with equal strength. Again, you are feeling forces rather than material substance. Every sensation of pressure or support is a message from your atoms interacting with the atoms around you. Once you begin to understand how matter behaves at small scales, the everyday world starts to look a little different. A drop of water becomes a collection of molecules bound together by forces. A metal spoon becomes a lattice of atoms sharing electrons. Even air, which feels almost like nothing at all, is full of molecules moving rapidly and bouncing off one another with lively energy. This perspective also shows why physical certainty can be stranger than intuition. It is common to think of atoms as tiny versions of the objects they make up, but the truth is far more unusual. Particles do not behave like miniature solid spheres. They do not sit still. They do not follow fixed paths. They exist in patterns that are probabilistic, dynamic, and often counterintuitive. And yet the combination of these behaviours creates a world that feels stable enough to trust. The idea that matter is mostly empty does not make the world less real. It makes it more fascinating. It reveals how much complexity lies beneath the surface of simple experiences. It shows how forces shape everything from the ground you walk on to the objects you hold. And it invites a sense of wonder at the thought that the solidity you rely on every day is the result of invisible interactions that never stop working on your behalf. Understanding the physics under your feet does not change the way the world feels, but it does add a layer of appreciation for how remarkable the physical world truly is. The ground remains firm, the walls remain solid, and the chair remains supportive, even though they are built from structures so delicate and spacious that intuition alone could never reveal their nature. And perhaps the most surprising part of all is how normal it eventually feels. Once you accept that solidity is a consequence of forces and interactions, the world becomes a place where emptiness holds you up, and motion creates stability. It is less like a collection of solid objects and more like a vast, organized dance of particles and fields, forming everything you touch, everything you see, and everything you call real. When scientists first examined the universe on the smallest scales, they expected to find tiny building blocks behaving in predictable ways. They imagined miniature versions of the familiar world, following neat paths and obeying clear rules. Instead, they discovered something far stranger. Particles did not behave like solid objects at all. They behaved like possibilities. They behaved like questions waiting to be answered. In the quantum world, reality does not unfold smoothly. It flickers between options, guided by probability rather than certainty. One of the most surprising ideas in quantum physics is that a particle does not have a single, definite position until it is measured. Instead, it exists in a cloud of possible locations, a spread of maybes rather than a single point. The particle is not lost or confused. It is simply described by probabilities. This concept is known as superposition. The particle can be in several different states at once, and only when you measure it does the probability collapse into a single outcome. This idea can be difficult to accept because it contradicts the way objects behave in everyday life. A coin on a table is either heads or tails. A cup is either upright or on its side. Nothing in your ordinary experience sits in multiple states at the same time. But at the quantum scale, superposition is perfectly normal. A particle can spin in two opposite directions simultaneously. It can take multiple paths through space. It can behave as though it passes through two slits at once in a famous experiment, not because it is confused, but because it follows the rules of quantum behaviour. This raises a natural question. If the microscopic world is built on uncertainty, why does the macroscopic world feel so solid and predictable? Why do tables, chairs, trees and planets behave in sensible ways when their building blocks do not? The answer is that quantum behaviour becomes less noticeable as you move to larger scales. When trillions upon trillions of particles combine, their individual uncertainties average out, creating the stable world you are familiar with. The quantum world underlies everything, but its peculiarities tend to cancel out when many particles interact. Even so, the quantum rules remain fundamental. They determine how atoms form, how electrons move, how light behaves, and how chemical reactions occur. Without quantum physics, matter as you know it could not exist. The world might feel stable, but its foundations rest on probabilities rather than certainties. Another aspect that challenged early physicists was the idea that observing a system seems to change it. This does not mean consciousness magically influences particles. Instead, it means that measuring a quantum system requires interacting with it. And at such small scales, any interaction affects the outcome. To measure a particle's position, for example, you must bounce something off it, such as light. That interaction disturbs the particle, altering its behaviour. The act of measurement changes what is being measured because the tools used to observe it are part of the same physical universe. This gave rise to the phrase, observation affects the outcome, which is often interpreted in dramatic ways. But the truth is simpler. The quantum world is delicate. Any attempt to examine it closely pushes it into a definite state. Before measurement, the particle exists in a superposition of possibilities. After measurement, it exists in a single, well-defined condition. The transition between these states is part of what makes quantum physics so fascinating. Yet it is important not to misunderstand this idea. The fact that quantum systems behave unpredictably does not mean that anything goes. The probabilities are governed by strict rules. Quantum mechanics is one of the most precisely tested theories in the history of science. It predicts outcomes with extraordinary accuracy. Even though individual events are uncertain, the overall patterns are consistent and reliable. The unpredictability is not chaos. It is structure that looks unfamiliar from the viewpoint of human intuition. The strangeness of quantum physics also challenges the idea of what is real. If a particle does not have a definite position until it is measured, does that mean it is not real beforehand? Some interpretations suggest that reality is not a single path but a range of possibilities that only settle into one version when observed. Other interpretations argue that the particle always has a position, but the theory does not let us know it precisely. And still others propose that the universe splits into branches for each potential outcome, though this idea can feel a little extravagant. Regardless of which interpretation you prefer, the key point remains the same. The quantum world forces us to rethink the idea that reality is fixed and definite at all times. Instead, reality might be something that becomes more definite the more closely you look, rather than something that exists fully formed in every moment. One gentle example comes from thinking about electrons inside atoms. The electron is not orbiting the nucleus like a tiny planet. Instead, it exists as a cloud of probability, spread out in a pattern that describes where it is likely to be found. When you measure the electron's position, you find it in a specific place, but before the measurement, it is not accurate to imagine it sitting somewhere waiting to be discovered. The cloud is part of the reality. It is a description of all the possibilities the electron could take. It can help to think of the quantum world as a set of layered behaviours. On the everyday level, objects behave predictably. They follow the rules you expect because the combined effects of countless particles smooth out the small uncertainties. But at the deeper level, the rules change. Particles dance between states. Probabilities guide outcomes, and the world unfolds in ways that defy simple pictures. The layered nature of reality can be comforting once you begin to understand it. The unpredictability of the quantum world does not threaten the stability of the macroscopic world. It enables it. The chemical bonds in your body rely on quantum rules. The way light interacts with matter relies on them as well. Even technologies like lasers, computers, and magnetic imaging depend on quantum effects. The strange behaviour at the smallest scales is not a flaw. It is the foundation of everything familiar. There is a quiet humour in the fact that the universe behaves sensibly on the surface only because, underneath, it behaves so strangely. The world you navigate every day is stable precisely because the quantum rules are so consistent at the microscopic scale. The oddity does not leak into your daily life in obvious ways. It remains hidden under layers of complexity, shaping everything without ever demanding your attention. The quantum realm invites curiosity not because it is chaotic, but because it reveals that reality is richer than intuition alone can capture. It shows that certainty is often an illusion, and that the universe is built from patterns of probability woven together to create the world you see. Understanding this does not require advanced mathematics. All it requires is a willingness to accept that the universe may be stranger than it first appears. The quantum world is not a place of confusion, but a place where the familiar rules bend just enough to reveal something deeper, something quietly astonishing. And once you begin to appreciate this strangeness, the everyday world takes on a new sense of wonder. The solidity around you, the light that reaches your eyes, the interactions between atoms, and even the structure of matter itself all depend on a world where possibilities rule and certainty is rare. Reality at its core is not a fixed picture. It is a tapestry of probabilities that settle into place only when you look closely enough to see them. Time is one of the most familiar parts of human experience. You wake up, the day unfolds, evening arrives, and eventually you return to sleep. Moments follow one another in a steady line, and it feels as though you are moving through them the way a boat moves along a river. The past sits behind you, the future waits ahead, and the present feels like a tiny island you occupy for only an instant. This sense of flow is so natural that it rarely occurs to anyone to question it. Yet both the brain and physics offer a very different story about what time actually is. From the brain's perspective, time is something constructed, not something passively received. Your sensory systems do not provide you with a built-in clock. Instead, your brain stitches together events, sequences, and changes to create the feeling of time passing. When the brain has more information to process, time can feel slower. When it has less, time can feel faster. That is why childhood summers feel endless and adult years seem to disappear as quickly as you stack them. The brain's way of tracking time is deeply tied to memory, attention, and how much novelty you encounter. It is not fixed, it is flexible. Even the feeling of now is not as simple as it seems. The brain needs a brief moment to process sensory signals, combine them, and present them as a cohesive experience. What you think of as the present moment is actually a slightly delayed, edited version of what is happening. The delay is tiny, but it means you never truly experience events in real time. The brain smooths everything together to avoid presenting a jumble of signals that would feel confusing. Your experience of the present is a biological construction that keeps your world feeling stable. Physics, on the other hand, treats time in a very different way. In many theories, time is not something that flows. It is not a river that carries you forward. Instead, time is a dimension, much like height or width. Past, present, and future all exist within the structure of space-time, and the division between them is not as absolute as it feels. If you move quickly relative to someone else, or sit near a stronger gravitational field, time will pass differently for you. This is not a trick of perception. It is a physical effect confirmed by experiments, including accurate time measurements on satellites and clocks flown on airplanes. In this view, the flow of time is not built into the universe. It is something the mind creates in order to make sense of change. The universe itself may not be marching from past to future in the way intuition suggests. Instead, all moments could coexist, forming a static landscape through which we perceive motion due to the workings of memory and consciousness. This idea does not mean that nothing changes. It means change is part of the structure, not something being carried along by a current called time. Your sense of time is also tied closely to how the brain manages information. When the brain anticipates what is coming next, time feels smoother. When something unexpected happens, time can feel stretched. A near accident, for example, can create a slow motion effect because the brain is suddenly hyper-focused, recording more detail than usual. When you're bored, every second seems to linger because the brain is not receiving much stimulation. When you are busy or distracted, time seems to vanish because your attention is elsewhere. These effects make time feel subjective, even though clocks tick steadily regardless of mood. The idea that the present moment is constructed by the brain also helps explain why people sometimes disagree about when something happened. Memory is not a perfect record. It is a reconstruction that changes slightly each time you recall it. When you remember an event, you are rebuilding it from fragments rather than retrieving a fixed image. This flexibility allows the brain to adapt, but it also means that your sense of when things occurred can shift without you noticing. One amusing thought follows naturally from all of this. Humans worry constantly about being late, rushing through life as though time were chasing them. Yet from the standpoint of physics, time is not rushing anywhere at all. If anything, humans are the ones doing the running while the universe sits quietly, unbothered by any schedule. So any time you're hurrying to make an appointment, you might gently remind yourself that if time is a dimension rather than a flowing force, then being slightly behind is not an offence to the universe, only to your calendar. The contrast between how time feels and how it behaves scientifically is striking. Your personal experience gives you a sense of movement, a story of moments unfolding one after another. Physics, however, describes a structure where moments are arranged in a four-dimensional shape, and the distinction between past and future is less rigid. The brain provides the narrative. Physics provides the framework. This does not mean your experience of time is an illusion in the sense of being false. It means it is a construction shaped by your biology. Illusions in the perceptual world often reveal how the brain processes information, and the same is true for time. The brain uses memory to create the past, attention to define the present, and anticipation to shape the future. All three components come together to create the feeling of moving through time. Even the idea of a beginning and an end is shaped by perception. A day feels like a flow from morning to night because you remember the beginning and anticipate the end. But in the physical sense, both the start and finish exist within a larger structure. The sense of travelling through them is part of your mental experience, not part of the universe's structure. Understanding that time may not flow as intuition suggests can be freeing in its own way. It gives you space to appreciate the present moment as something the mind crafts with care. It shows that the hurried feeling of time slipping away is part of human psychology rather than a law written into the universe. And it reveals that the reality of time is far more interesting than a simple line stretching from yesterday to tomorrow. Time, in many ways, is a partnership between the physical world and the mind interpreting it. You live inside a universe where clocks tick predictably according to laws of physics, while your brain translates those ticks into a lived experience that feels rich, continuous, and full of meaning. The universe provides the structure. The mind provides the story. And that story, even with all its quirks and distortions, is what gives life its rhythm. Without the feeling of time passing, memories could not form, anticipation would not exist, and life would lose much of its shape. Whether time flows or sits quietly as a dimension, your experience of it remains one of the most remarkable features of being human. Space is often imagined as a giant container, an endless black backdrop where stars float, planets circle, and galaxies drift slowly apart. It feels like a stage, something empty and passive, holding everything else in place while remaining unchanged itself. But space is far from a simple void. It is one of the most active ingredients in the universe, shaping motion, influencing time, and curving gently around anything with mass or energy. What appears empty and silent is in reality a dynamic fabric with a personality of its own. The idea that space could be flexible rather than rigid first gained attention in the early 20th century, when scientists realized that gravity might not be a force in the traditional sense. Instead of thinking of objects pulling on each other, they began imagining that mass bends the space around it, and objects move along the curves created by that bending. A planet orbits a star not because it is being tugged, but because it is following the natural path laid out by curved space. It is similar to a ball rolling along a gently tilted surface, except the surface is invisible and exists in every direction at once. This picture can feel strange at first because humans live in a world where distances seem fixed. If you walk across a room, that distance does not appear to change. If you measure the length of a table, it stays the same. Yet when you step into the realm of relativity, distance becomes more fluid. When an object moves quickly, lengths can appear to contract. When it sits in a strong gravitational field, space can stretch or compress. These effects are tiny at everyday speeds and sizes, which is why intuition never notices them. But in the universe at large, they matter enormously. The flexibility of space becomes clearer when you think about motion. Imagine two people on opposite sides of a large field. They agree to walk toward each other. In the everyday sense, the distance between them simply shrinks as they move. But in the language of physics, the space between them can be described as changing shape as they travel through it. This might seem like a technicality, but it reflects a deeper truth. Space and motion are intertwined. The path you follow is not just a line drawn through emptiness. It is a journey through a structure that has form and behaviour. This connection between motion and space becomes even more interesting when you think about the speed of light. Nothing can move through space faster than light can, no matter how much energy you give it. This limit reveals that space itself plays a role in defining what is possible. Instead of being a passive container, space sets the rules. It decides how fast something can move, how long a journey will take, and how objects interact across distance. One of the most remarkable ideas to emerge from modern physics is that space can stretch. The expansion of the universe is not galaxies flying through empty space like shrapnel from an explosion. Instead, the space between galaxies is increasing. The galaxies remain mostly still relative to their local surroundings, while the fabric between them expands. This stretching does not pull objects apart within galaxies because the gravitational forces inside them are strong enough to resist it. The expansion happens on vast scales, slowly altering the shape of the cosmos. The idea that space can stretch raises natural questions about what space actually is. If it can curve, flex, and expand, then it is more than a simple backdrop. It is part of the physical world. It interacts with matter. It carries energy. It shapes the growth of structures from small clusters of stars to entire galaxy formations. The universe is not simply in space. The universe includes space as one of its core components. Curvature adds yet another layer to this story. When you drop an object, you might think it falls straight downward because gravity pulls it. But from the point of view of curved spacetime, the object is following the straightest possible path through a warped landscape. This path is called a geodesic, and it is similar to the way a plane flying around Earth follows a curved route, because Earth itself is curved. Space shapes the motion, and the motion reveals the shape of space. Because humans evolved to navigate a world where these effects are incredibly small, intuition can sometimes mislead. Space feels rigid because at everyday scales it behaves that way. You do not notice curvature when walking across a room. You do not notice time running more slowly at your feet than at your head, even though it does. These effects are far too tiny to matter in routine life, but they become significant around massive objects such as stars and black holes, or at speeds approaching the speed of light. Despite its flexibility, space still provides structure. It allows distances to be measured, paths to be followed, and objects to be located relative to one another. At the same time, it remains far more dynamic than common sense suggests. It responds to mass and energy. It influences the passage of time. It expands over cosmic scales. It curves around stars and stretches between galaxies. The quiet emptiness that seems so still is full of subtle motion. There's a gentle humour in realising that humans, who often struggle to be on time for appointments, live in a universe where space and time themselves bend and stretch without asking permission. If you are ever late, you might take comfort in the idea that even the universe cannot maintain a perfectly rigid schedule. Understanding space as a flexible fabric does not make the world less real. Instead, it gives shape to the forces that govern everything you see. It explains how planets move, how light behaves, and how the cosmos evolves. It connects the familiar world to the deeper rules operating beneath it, showing that the universe is both elegant and surprising. What feels rigid and predictable turns out to be responsive and alive with structure. What seems empty is full of influence. The distance between 2 points is not always as straightforward as it appears, and the space around you, silent and transparent, quietly participates in every moment of existence. When you think about yourself, it feels natural to imagine a single stable identity, a continuous you moving through life, collecting memories, making choices, and staying essentially the same from one moment to the next. This sense of a unified self is so familiar that it often goes unquestioned. Yet beneath this comforting picture lies a surprising truth. The self is not a fixed thing. It is a process, constantly rebuilt, updated, corrected, and reinterpreted by the brain. What you call you is less like a solid statue, and more like a story the brain keeps revising. At any given moment, countless signals move through the brain. Thoughts rise and fall, emotions shift, perceptions flicker, neurons fire in patterns that change from second to second. There is no single location in the brain where the self is stored. Instead, identity emerges from the ongoing conversation between many regions working together. The sense of being one continuous person comes from the stability of this conversation, not from a specific structure or substance. A helpful way to think about it is to imagine a river. A river looks stable when you view it from a distance. You can name it, point to it, and recognize it year after year. But the water flowing through it is never the same. It is always moving, always changing. The river endures because the pattern endures, not because the content stays still. The self works much in the same way. The neural patterns that create your personality and identity persist over time, but the individual thoughts, memories, and perceptions inside them are constantly shifting. The brain supports this sense of continuity through storytelling. Humans are natural narrators, even when they do not realize it. Throughout the day, the brain interprets your actions, decisions, and experiences, weaving them together into a coherent story that feels like a single, unified life. This storytelling happens automatically. When something unexpected occurs, the brain quickly explains it to maintain a sense of consistency. If a memory is unclear, the brain fills in details. If you act differently from how you imagine yourself, the brain creates a reason that fits your ongoing narrative. This storytelling machinery is incredibly useful. It helps you understand yourself, predict your own behaviour, and make sense of your choices. But it also means that the self is less stable than it appears. The narrative is a construction, not a recording. It changes subtly with new experiences, altered moods, or shifting beliefs. Sometimes it changes dramatically, such as after large life events or strong emotional experiences. The story adjusts and the sense of self adjusts with it. Memory plays a major role in maintaining this illusion of stability, but memory is far less reliable than most people imagine. Memories are not stored like files in a cabinet. They are reconstructed each time you recall them. During this reconstruction, details can shift. New information can blend with old. Emotions can reshape the memory, making it feel different than it was. Sometimes the brain fills in missing pieces without you noticing. These changes are not deceptions. They are part of how the memory system works to keep your personal narrative coherent. Because memory is so fluid, the past you remember is not always the past that happened. It is the past interpreted through your current perspective. This interpretation helps the brain maintain a stable story about who you are, but it also shows how easily the self can shift. A change in mood or a new understanding can alter a memory's meaning, and with it, the way you see yourself. Even perception contributes to this process. The brain constantly filters information to match your expectations. If something does not fit your sense of who you are, the brain may downplay it or reinterpret it. This selective attention allows you to maintain a coherent identity, but it also means that some parts of reality get smoothed over. You experience a version of the world that supports your internal story. This adaptive storytelling is part of what makes the self feel stable. The brain does not treat each moment as a separate event. It links them together into an ongoing narrative that makes sense at the time. You feel like the same person you were yesterday because the brain connects those memories to the present moment. You feel like the same person you were 10 years ago because the story has woven all those moments together. Yet biologically, you have changed. Your brain has formed new connections. Your body has renewed itself. Your beliefs and behaviours have evolved. There is a gentle humour in realising that the self, which feels so steady, is actually one of the brain's most impressive illusions. It is not a trick meant to fool you. It is a useful structure that helps you function. Without a stable sense of self, navigating life would be far more difficult. Decisions would feel disconnected. Goals would lose their meaning. Relationships would lack continuity. The illusion supports your ability to learn, plan, and connect with others. Some scientists and philosophers go even further, suggesting that the self is not a thing at all, but a process unfolding moment by moment. In this view, the self is like a flame. The flame looks constant, but it is always being recreated by the burning fuel. Remove the fuel, and the flame disappears. The flame exists because of the process, not because of a solid object. Likewise, the self exists because the brain continuously recreates it through perception, memory, and interpretation. Accepting this idea does not diminish personal experience. Instead, it adds richness to it. It reveals how adaptable the mind is. It shows how identity can grow and change. It explains why you might look back at your younger self and feel both connected and distant at the same time. You are the same river, but the water has changed. Understanding that the self is constructed can also be a source of comfort. When your identity feels uncertain or in transition, it may help to remember that the brain is always updating the story. Change does not mean losing who you are. It means the process is continuing. A flexible self is capable of growth, and the narrative can shift in ways that bring clarity, meaning, and resilience. The illusion of a stable self is one of the most convincing illusions of all, not because it hides the truth, but because it creates something deeply useful. It provides a center of gravity for your experiences. It allows the mind to organize life into a story that feels unified and meaningful. And even though the self is constructed, it is no less real in its effects. It shapes your choices, relationships, and aspirations. In the end, the self is both an illusion and a truth. It is an illusion because it is constantly changing, and a truth because it feels coherent. The story you live with is not perfect, but it is your story, rebuilt each moment and woven together by a mind doing its best to make sense of the world. Dreams are one of the clearest demonstrations of the brain's ability to create entire worlds from almost nothing. When you fall asleep, the outside world fades, your senses quieten, and the brain begins constructing landscapes, characters, stories, and emotions with astonishing ease. You may find yourself standing on a beach that never existed, flying through a city that has no counterpart, or talking to someone who's been gone for many years. These dream scenes feel vivid and convincing, even though every detail is generated internally. Nothing external is required. The brain becomes artist, architect, narrator, and actor, building an entire reality from within. What makes dreams so striking is how effortlessly they appear. You do not plan them. You do not consciously design their environments or events. Instead, the dreaming brain assembles them spontaneously. This process reveals something profound. The brain does not need input from the physical world to create a believable experience. It can generate light without photons, sound without vibrations, touch without physical contact. Dream perception is built from the same neural machinery you use when awake. The key difference is that the brain is not constrained by sensory input, so it fills the space with whatever patterns arise from memory, imagination, or emotion. Much of this activity occurs during rapid eye movement sleep, a stage where the brain becomes highly active while the body remains still. During this time, regions involved in visual processing, emotional experience, and memory become particularly lively. The prefrontal areas responsible for logical thinking, decision-making, and critical evaluation tend to quieten. This combination creates the perfect environment for unusual or impossible events. Without the usual oversight, the brain allows ideas to flow freely, blending fragments of experience into scenes that would never occur in waking life. The neuroscience behind dreams helps explain why they feel so immersive. The visual cortex lights up as though you were seeing something real. The auditory areas activate as though you were hearing sounds. The emotional centers respond as though events were happening to you. Because the same networks used in waking perception are active, the dream feels genuine. Your brain is not pretending to see or hear. It is using the actual perception systems, just without input from the external world. This also explains why dreams can feel so emotionally powerful. Without the balancing influence of the rational mind, emotions can rise unfiltered. A pleasant dream can feel deeply peaceful. A confusing dream can feel mysterious. A frightening dream can feel overwhelmingly real. The emotional intensity often reflects the brain's tendency to process unresolved feelings or reorganize recent memories. Dreams can highlight things you've been thinking about, worrying about, or ignoring, weaving them into symbolic narratives that make sense only in that fleeting state. One of the most intriguing features of dreams is how they blur the boundary between the real and the imagined. While dreaming, the events feel authentic. A stranger can speak to you, and you respond naturally. You can walk through a landscape you've never seen, and it feels as though your feet are moving. You can read a sign, talk to a friend, taste food, or feel warmth on your skin. All of these sensations are constructed within your mind, yet the experience feels fully lived. Only upon waking do the edges soften, revealing how fluid the dream reality was. This boundary blurring offers a subtle lesson about the brain's ability to create coherent worlds. If the mind can build such rich scenes during sleep, it suggests that perception itself depends heavily on interpretation. Waking life may feel more grounded, but the brain still constructs your experience using the same networks it employs during dreams. The difference is that, when awake, the sensory input anchors the construction. Dreams simply show what happens when the anchor is removed. Some people find it amusing that their dream selves can behave unpredictably, doing things they would never do while awake. This happens because the dreaming brain is not tied to the usual rules of identity. With the logical machinery dialed down, the self becomes more fluid. You might accept impossible situations without question, or feel emotions that do not match the narrative. The dream self is as constructed as the dream environment, shaped moment by whatever the brain puts together. There is a quiet beauty in observing how dreams unfold. Many dreams drift from scene to scene without clear transitions, as though you are walking through misty landscapes where each step brings a new setting. One moment you may be standing in a familiar room. The next you may be floating above a forest at dusk. Trees sway below you, illuminated by soft moonlight. A calm wind carries you forward. Then, without warning, you find yourself returning to childhood, visiting a place long forgotten. The scenery dissolves and reforms with gentle fluidity. These transitions often feel natural, even though they defy logic. Dream time does not flow in the same way as waking time. Minutes can feel like hours or vanish in an instant. You can move great distances without taking a single step. Events appear without cause, yet feel perfectly acceptable while they unfold. The mind accepts these shifts because the mechanisms responsible for questioning and checking reality are resting. Some dreams carry a sense of deep calm. You might find yourself drifting through a quiet lake at twilight, the water perfectly still. The surface reflects the sky, dotted with stars that shimmer gently, as if they were floating nearby. You feel weightless, peaceful, unhurried. There is no story, no urgency, only the sensation of drifting. The brain creates these scenes not to deliver a message, but simply because it can. Dreams are the mind's opportunity to explore without constraints. Other dreams are more playful. The brain sometimes uses sleep as a space to rehearse ideas, imagine possibilities, or reorganize memories. You might dream of solving a problem, navigating a maze, or performing a task you attempted earlier in the day. These dreams are part of how the brain strengthens learning. They show that sleep is not a passive state but an active one, where the mind experiments with different versions of the world. The ability to dream also highlights how fragile the distinction between waking and sleeping reality can be. When you wake from a vivid dream, the emotions can linger. You may feel a sense of loss, relief, curiosity, or amusement. The dream world may disappear, but the feelings remain. This continuity reinforces the idea that the brain treats dream experiences as meaningful, even if the events never occurred in the physical world. Understanding dreams deepens the appreciation of how creative and adaptable the brain truly is. The dream state shows that the mind can generate entire environments, full of detail and sensation, without a single external input. It demonstrates how perception depends on interpretation, how memory blends with imagination, and how consciousness flows through different states with remarkable ease. Dreams remind us that reality is not only what happens outside us, but also what happens within. The landscapes you explore at night are built from memory, emotion, and imagination. woven together into stories that feel mysteriously real. They offer a glimpse into the brain's experimental sandbox, a place where anything can happen, where logic can rest, and where the mind is free to wander through endless possibilities. The idea that reality might be a simulation has captured people's imaginations for decades. It appears in films, novels, late-night conversations, and more recently, in philosophical discussions and scientific debates. The basic question is simple to ask, yet difficult to answer. Could everything you experience, every sound, every colour, every memory, every sensation, be part of a vast computational system? Could the universe itself run on rules similar to a program, with reality emerging from layers of information rather than physical substance? To explore this calmly, it helps to start by clarifying what the simulation hypothesis actually suggests. It does not claim that life is a video game, or that complex beings are sitting outside the universe pressing keyboard shortcuts to control your day. The idea is far more subtle. It proposes that, if a civilization in the distant future developed extraordinary computing power, they might be able to simulate conscious beings within a virtual environment, complete with the appearance of physical laws. If such simulations were possible and numerous, the argument goes, it might be more likely that you're inside one of them rather than in the original base reality. This thought experiment raises interesting questions about the nature of existence. If a simulated world were detailed enough, would its inhabitants be able to tell the difference? How would consciousness arise within such a system? What clues might hint at the underlying structure? These questions belong as much to philosophy as to physics, and they spark curiosity precisely because they sit on the boundary between what can be tested and what must be reasoned through. One of the more entertaining aspects of the simulation idea comes from imagining glitches or updates. People sometimes joke that strange coincidences or oddly timed events must be the simulation adjusting itself. A familiar example is opening the fridge multiple times, hoping that new food might appear, as though the simulation could be persuaded to refresh its inventory. Of course, nothing actually updates, except perhaps your mild disappointment. But the humour reflects how easily the mind plays with the idea once it is introduced. While the simulation hypothesis is fun to think about, scientists approach it with caution. Science relies on testable predictions, and many aspects of the simulation argument are not easily testable. That does not make the idea wrong. It simply places it in a category where scientific tools may not be able to provide clear answers. At the moment, there is no direct evidence that reality is a simulation. There's also no definitive evidence that it is not. This uncertainty leaves room for philosophical exploration without requiring dramatic conclusions. Some researchers have considered whether the universe might contain signs of underlying computational limits. For instance, if space and time were discrete rather than continuous, like pixels on a screen, certain physical patterns might reveal that structure. Likewise, if energy levels had specific constraints, or if cosmic rays behaved in unusual ways, those might hint at a deeper grid beneath the surface. So far, however, observations have not shown such limitations in any definitive way. The universe behaves smoothly and consistently, without obvious evidence of being generated by an external processor. Another angle comes from thinking about the sheer amount of computation required to simulate an entire universe. Even with unimaginable future technology, the idea of calculating every particle, every field, every atom, and every interaction is staggering. Some versions of the hypothesis get around this by suggesting that only the parts of the universe being actively observed would need to be fully rendered. similar to how a computer game loads the environment around the player. This leads to the amusing mental image of distant galaxies existing in a kind of low resolution until someone points a telescope at them. While this is humorous, it is still speculative. A more grounded question concerns consciousness. If reality were computed, could consciousness emerge from a sufficiently complex simulation, or would it require something fundamentally different? This is an active philosophical debate. Some argue that consciousness depends on physical processes in a real universe. Others believe that consciousness arises from patterns, meaning it could emerge wherever those patterns exist, including a simulated environment. The truth remains uncertain. It is worth noting that the simulation argument is not new in spirit. Philosophers have long wondered whether perception reflects the world directly, or whether it is mediated by something deeper. In the early 20th century, discussions about idealism and the nature of reality explored similar territory, just without the technological vocabulary. The simulation hypothesis rephrases ancient questions in modern language, giving familiar ideas a fresh context. For all of its speculative nature, the hypothesis does highlight something important. Whether reality is simulated or not, your experience of it is filtered through the brain. You already live within a constructed version of the world shaped by perception and interpretation. The universe outside your mind sends information, but the world you experience is assembled internally. That alone creates a kind of simulated reality, one built not by computers but by biology. This perspective helps keep the simulation idea in balance. It is an interesting possibility, but not a necessary one to explain why human experience feels constructed. The brain is capable of creating a coherent world without any external programmer involved. The simulation argument simply extends that concept to the entire universe. In considering what science can and cannot say, it becomes clear that the simulation hypothesis sits in an unusual space. It is neither proven nor disproven, neither required nor dismissed. It is a question that invites curiosity rather than certainty. Science can explore the limits of computation, the structure of space, and the behaviour of physical laws. It can look for anomalies or patterns that might hint at deeper layers, but it cannot easily determine whether the universe itself is running on an invisible computational substrate. The philosophical implications are equally intriguing. If the universe were a simulation, would that change the meaning of life, relationships, creativity, or experience? Many would argue that it would not. A simulated sunset is still beautiful if it evokes a sense of peace. A simulated act of kindness is still meaningful if it strengthens a bond between people. Reality has value not because of its underlying structure, but because of how it is lived. Whether the world arises from physics alone or from some deeper informational foundation, the experience remains real to those within it. In the end, the simulation hypothesis is neither a threat nor an answer. It is an invitation to think about reality in a broader way. It encourages questions about the foundations of physics, the nature of consciousness, and the role of perception in shaping what feels real. It blends science with philosophy in a way that can be both playful and thoughtful, allowing people to explore possibilities without needing final conclusions. And perhaps, after exploring these ideas, the next time you open the fridge hoping for a surprise appearance of snacks, you might smile at the thought that if this is a simulation, the programmers clearly enjoy keeping things consistent. Or maybe they simply want you to do your own shopping. If you have ever described something to a friend and discovered they imagined it completely differently, you have experienced one of the quiet truths of being human. No two people see the same world. Even when looking at the same scene, Listening to the same sound or recalling the same memory, each person's experience is shaped by the unique workings of their senses, their brain, and the story they carry with them. Reality, at least the version each person lives through, is filtered through individual perception. To begin with, sensory differences play a large role. Eyes vary in how they detect light. Some people see colours more vividly, while others see narrower ranges. A sunset may appear rich and glowing to one person and softer, more muted to another. Hearing differs as well. One person may catch faint background sounds that another cannot. Someone else may be sensitive to tones that go unnoticed by most. Even taste and smell show enormous diversity. Food that seems delicious to one person may taste unbearably bitter to someone else, not because the food changed, but because their sensory receptors send different signals. These variations are natural and constant. Even when two people describe the same object, they are describing two slightly different sensory experiences. This alone makes perception deeply personal. But the differences do not end with the senses. The brain also interprets sensory information in ways shaped by memory, expectation, culture, and attention. This is where cognitive biases begin to shape how each person understands the world. Biases are not flaws. They are shortcuts the brain uses to make sense of information quickly. They help you focus on what matters, ignore what does not, and reach conclusions efficiently. But they can also guide interpretation in subtle ways. For instance, if you expect a dog to be friendly, you may interpret its movement as playful. If you expect it to be aggressive, the same movement might seem threatening. The event is identical. The perception is not. Memory plays a role too. Each person brings their own history to a moment. A smell might remind someone of a childhood comfort, and someone else of a difficult experience. A song might evoke joy in one listener and sadness in another. The same stimulus becomes many different realities because it interacts with different pasts. And because memory is reconstructed rather than replayed, the details shift slightly each time, further shaping how new experiences are interpreted. Attention also filters reality. When you focus on something, everything else fades into the background. Two people can walk through the same street and notice entirely different things. One might observe architecture. Another might notice the sounds of traffic. Someone else might focus on the expressions of people passing by. None of these perceptions are wrong. They're simply shaped by what each person finds meaningful or relevant. All of these filters contribute to the astonishing diversity of subjective experience. There is something quietly beautiful about this. Each person carries a private world, built from the same physical environment, but shaped by different inner landscapes. It means that every conversation, every memory, every shared event is slightly different for each participant. People often assume that their perception is the default or the most accurate, but in truth, everyone is living inside a personalized version of the world. Despite these differences, humans manage to communicate and build shared understanding. This is where language becomes essential. Words allow people to point to their personal experiences and find common ground. When you describe a color as blue, you and someone else may not see exactly the same shade, but the word creates a shared reference point. When you say something tastes sweet, the sweetness one person experiences might differ from another's, but the concept aligns your experiences enough to understand each other. Language does more than label perception, it shapes it. Studies have shown that people with different linguistic categories for colors can perceive shades differently. People who speak languages with distinct terms for certain spatial directions navigate differently from those who rely on left and right. Language guides how people carve the world into meaningful pieces. It stabilizes shared reality by giving everyone a common toolkit for describing their personal one. This shared toolkit allows society to function. It lets people agree on instructions, collaborate on tasks, and discuss abstract concepts. Without language, subjective realities would remain isolated. With it, people can compare, clarify, and sometimes even reshape their perceptions. Language acts as a bridge, connecting internal experiences that might otherwise remain completely separate. There is gentle humour in realizing that much of human misunderstanding comes not from disagreement about facts, but from differences in perception. Two people may argue about whether a room feels cold or warm, while both are correct according to their bodies. Someone may describe a task as easy, while someone else finds it difficult, and both perspectives are true from within their own filters. Once you recognize that everyone sees the world slightly differently, interactions become a little softer, a little more patient. This understanding also encourages curiosity. If no two people see the same world, then every perspective holds something unique. Asking how someone experiences a moment becomes a window into a reality you could never access on your own. Even familiar places can look new when described through another person's eyes. The diversity of perception is not a problem to be solved. It is a source of insight and connection. Subjective reality also reminds you of how flexible perception can be. When you learn something new or change your expectations, your experience can shift. A food you disliked may become enjoyable. A sound you ignored may become soothing. A place that once felt intimidating may begin to feel welcoming. The filters can adjust, allowing your world to evolve as you do. Understanding perception filters also highlights the importance of empathy. Recognizing that other people live in slightly different versions of the same world encourages patience when experiences do not align. Someone else's emotional reaction may come from a part of the world you cannot see. Their interpretation may be built on memories you do not share. Their perspective may be shaped by senses that respond differently from yours. When you appreciate this diversity, it becomes easier to meet people where they are rather than where you expect them to be. In the end, the fact that no two people see the same world does not divide reality. It enriches it. It means that the world is large enough to hold infinite variations, each shaped by the mind that experiences it. It means that the shared reality people build together is not a single picture, but a mosaic of perspectives, reflections, and interpretations. Each person carries a slightly different world within them, and yet, through language, connection, and understanding, these worlds overlap enough to create a society, a culture, and a shared sense of meaning. And in that overlap lies the quiet wonder of being human. Illusions are small reminders that the world you experience is not a direct recording of what exists outside you. They reveal the quiet machinery of the mind, how it fills gaps, smooths edges, corrects errors, and makes predictions to create a stable version of reality. Most of the time, this process works beautifully, giving you a world that feels consistent and reliable. But every so often, a simple trick of light or sound can pull back the curtain and show how much interpretation is involved in what you see and hear. Optical illusions are perhaps the most familiar. Consider the experience of looking at two lines that appear different in length, even though they are identical. No matter how many times you measure them with your eyes, one looks longer. The mind is not being foolish. It is applying a lifetime of experience about depth, perspective, and distance. The illusion works because the brain guesses what it thinks the lines should be, not what they are. When the guess is wrong, the illusion appears. Another gentle example comes from colour illusions. Two squares placed in different lighting conditions may look like completely different shades, even when they are physically the same colour. The brain corrects for shadows and brightness automatically, assuming that objects should retain their colour regardless of lighting. This is a useful assumption in daily life, but it leads you astray in controlled situations designed to catch the brain in the act. When the illusion is pointed out, you may know intellectually that the squares match, but your perception stubbornly insists they do not. The brain's correction is too deeply ingrained to override with logic alone. Auditory illusions show similar behaviour. In a noisy place, you might hear someone call your name, only to realise that no one actually did. The brain expects certain sounds in certain contexts and fills in the rest. One well-known demonstration involves a repeated sound that the brain interprets differently depending on what you expect to hear. When the sound is paired with different written words, your mind reshapes the noise to match the text, even though the audio never changes. This reveals how strongly expectation influences perception. Another amusing example is when a rhythmic pattern seems to speed up, slow down, or change shape even though it remains constant. The brain tries to organize the sound into patterns that make sense, and when those patterns shift, the perception shifts with them. It is not the sound that changes, but the brain's interpretation of it. Cognitive illusions take this even further by showing how the brain sometimes jumps to conclusions based on incomplete information. Imagine reading a sentence with a repeated word such as the and not noticing the duplication. The mind smooths it out automatically because it expects the sentence to follow normal structure. Or think about instances where you swear you saw something out the corner of your eye, only for it to vanish when you turn your head. The brain fills in details when it lacks clarity, creating brief moments of perception that may not match the external world. One gentle example involves ambiguous images, such as a drawing that can be interpreted in two different ways. At first glance, you might see a rabbit. A moment later, you might see a duck. Both interpretations are possible, and the brain switches between them depending on tiny cues. The image itself does not change, your perception does. This reveals how actively the mind participates in shaping what you experience, even when the information is unchanging. These illusions highlight a central feature of perception. The brain does not measure reality directly. It predicts. It uses patterns, experience, and context to make its best guess about what is happening. Most of the time, these guesses are accurate enough to navigate the world without difficulty. But illusions expose the shortcuts. They show where prediction overrides fact, and how the brain fills in gaps with remarkable confidence, even when the result is wrong. This predictive style of perception makes sense from an evolutionary standpoint. The brain must work quickly to interpret the world. There is no time to analyze every photon or sound wave that reaches you. Instead, it relies on patterns learned over a lifetime. When something looks like a shadow, the brain adjusts the color. When something sounds like speech, it assumes meaning. When a shape resembles a familiar object, the brain labels it instantly. This saves time and energy, but it occasionally misfires in situations designed to trick it. Illusions remind you that the world you see is partly created by the mind. They make reality feel sturdy because the mind usually interprets things correctly. You trust your senses because they serve you well in daily life. But illusions also make reality feel fragile because they reveal how easily perception can be nudged into a different interpretation. A small shift in context or lighting can change the entire experience. This mixture of sturdiness and fragility is part of what makes illusions so fascinating. They do not undermine the idea of reality. Instead, they show how much interpretation lies between the world and your experience of it. The physical world is stable, but your perception of it is dynamic, constantly adapting and adjusting. Illusions are moments where that adaptation becomes visible. There is a gentle humour in the way illusions expose the brain's confidence. Even when you know an illusion is at work, your perception rarely corrects itself. You can measure the lines, adjust the colours, replay the audio, and the illusion remains. It is as though the brain politely acknowledges your efforts, then returns to doing things the way it always has. The prediction machinery continues because it must. It keeps the world flowing smoothly. Illusions can also be grounding in an unexpected way. They remind you that perception is flexible. They show that differences in how people see or hear things are natural outcomes of how the brain works. If someone else interprets a situation differently, it may not be because they are wrong, but because their brain made a different prediction. Perception is personal, and illusions provide small windows into that individuality. Perhaps the most important lesson illusions offer is the reminder that the world is richer than what is immediately visible. If the brain can make confident mistakes based on context, then the understanding of reality is partly shaped by hidden processes. This does not make the world less real. It simply means that the experience of reality is a collaborative effort between the external world and the internal machinery interpreting it. Illusions, in their quiet way, reveal how extraordinary that machinery is. They show the brain working at incredible speed, assembling a coherent world from limited information. They demonstrate how perception blends prediction with sensation, and how this blending allows you to move through life with ease. And though illusions may momentarily trip up that system, they also celebrate its ingenuity, reminding you that reality, as you experience it, is both wonderfully reliable and endlessly surprising. When you look at the world around you, it feels full of distinct, solid, meaningful things. A flock of birds moving in perfect coordination, patterns of ripples spreading across a pond, the swirling structure of a galaxy, the smooth curve of a sand dune shaped by years of wind. All of these scenes appear purposeful, almost deliberate, as though shaped by a guiding intelligence. Yet beneath the surface, each of them arises from simple rules followed by countless individual parts. This process, where complexity emerges from simplicity, is known as emergence, and it is one of the most remarkable features of the universe. Emergence begins with a simple idea. Small things acting according to basic rules can create behaviour that looks far more complex than the parts themselves. A single bird in a flock does not know the shape the flock will form. It follows just a handful of instincts. Keep a comfortable distance from neighbours, match their speed, and avoid obstacles. When thousands of birds follow these same rules, their combined motion creates the sweeping, fluid shapes often seen at dusk. The flock moves as though it were a single organism, even though no bird is in charge and no plan exists. The complexity appears real and intentional, yet it arises naturally from many simple interactions. Another example appears in the tiny world of ants. An individual ant is not especially intelligent. It cannot understand the shape of the colony or the structure of the nest. But when thousands of ants move, react, and share chemical signals, they build intricate underground cities, efficiently organize food gathering, and solve problems that seem far beyond the capabilities of any single ant. The colony behaves like a unified mind, even though no ant understands the full system. Intelligence emerges from interaction, This same pattern shows up in physical systems. Snowflakes form from water molecules following straightforward bonding rules, yet the resulting shapes appear delicate and intricate. Sand dunes arise from wind moving individual grains, but the dunes themselves take on elegant curves that can stretch for kilometers. Even the colors of certain butterfly wings arise not from pigment, but from microscopic structures that bend light in complex ways. What looks magical often turns out to be the product of simple processes repeated many times. This reveals something important about reality. The world at one scale does not necessarily resemble the world at another. At the level of particles and fields, everything is probabilistic and constantly shifting. But at the human scale, you see stability. You see mountains, trees, clouds, faces. The stability is not an illusion, but it is the result of countless smaller interactions. The rules at the lower level give rise to the patterns at the higher level, and those patterns become the reality you experience. Water offers a particularly clear example of emergence. A single water molecule cannot flow, splash, freeze, or boil. It cannot create waves or fill a glass. But when trillions of molecules interact, water gains properties that seem nothing like its parts. It flows effortlessly, holds surface tension, and shapes itself to its container. These behaviours emerge from the way molecules attract and repel one another. A property like wetness is not something any single molecule possesses. It arises only when many molecules come together and behave collectively. Life itself is one of the most impressive emergent phenomena. Cells obey chemical rules. Proteins fold and react. DNA stores information. None of these components alone could be called alive. But when arranged in particular ways, with countless interactions and feedback loops, life emerges. Consciousness emerges, experience emerges. The mind, with all its richness, arises from neurons communicating through electrical signals. The individual neuron has no thoughts, but together they create a thinking, feeling, perceiving being. These examples show that emergence acts as a bridge between the simplicity of fundamental physics and the complexity of the world as you experience it. It explains how the same universe can contain both the unpredictability of quantum behaviour and the reliability of everyday life. It shows how a world built from particles and forces can appear full of shapes, meanings, and structures that feel wonderfully real. The idea that reality depends on scale can be surprising at first. If someone asks what a tree is made of, you might say wood or cells or atoms. But at the scale where you experience the tree, none of these smaller components matter. You see roots gripping the soil, branches swaying in the wind, and leaves shifting colour with the seasons. The tree is an emergent form created from the coordinated interaction of smaller parts. The tree is real, even though it does not resemble the particles that compose it. Emergence also helps explain why certain patterns in nature feel almost universal. Spirals appear in seashells, galaxies, hurricanes, and ferns. They arise because simple geometric rules repeat at different scales. Stripes and spots form on animals not because of artistic intention, but because of chemical gradients spreading across developing skin. Even the way clouds form and shift follows straightforward physical laws applied many times across vast numbers of water droplets. The beauty of emergence is that it allows the universe to create complexity without needing complexity at the fundamental level. Simple ingredients, arranged in the right way, can produce an astonishing range of structures, behaviours, and phenomena. This means that the world is full of patterns waiting to be discovered, each revealing something about how nature builds itself from the ground up. There's also a gentle humour in realising how often humans attribute intention to emerging patterns. When a murmuration of starlings twists through the sky, it can look like a single creature changing shape. When a school of fish moves in perfect harmony, it seems as though they share one mind. In a way, this misunderstanding is part of the wonder. Emergence produces patterns so coordinated that they feel intentional, even though they arise automatically. Emergence also demonstrates why reality can feel incredibly stable at one scale and wildly unpredictable at another. The behaviour of individual particles may be uncertain, but large collections of them behave reliably. This is why a snowball rolls predictably down a hill, even though the molecules within it are vibrating chaotically. The collective behaviour smooths out the randomness. Stability emerges from complexity. Understanding emergence adds a new dimension to the appreciation of reality. It shows that complexity does not need a designer, nor does stability require rigid structure. The world is full of organised forms that appear naturally whenever the right conditions are present. Patterns arise from repetition. Behaviours arise from interaction. Reality becomes layered, with each layer telling a different part of the story. The bridge between illusion and truth becomes clearer through emergence. The patterns you see may feel intentional, but they can arise without intention. The forms you observe may feel solid, but they come from processes that are dynamic beneath the surface. The world is not an illusion, but neither is it as simple as it first appears. Emergence shows how meaning arises from simplicity, how complexity grows from interactions, and how the universe builds its beauty step by step. The more you look at nature through this lens, the more remarkable it becomes. A swirl of cream in coffee becomes a tiny example of fluid dynamics. A patch of moss becomes a network of interactions. A single leaf becomes the endpoint of a long chain of emergent processes. And in recognizing these layers, reality feels deeper, richer, and more astonishing than ever. Consciousness is perhaps the most familiar thing in your life and at the same time the most mysterious. It is the quiet presence behind every thought, every sensation, every moment of awareness. Without consciousness, the world would continue on exactly as it does now, but there would be no one to experience it. That simple fact places consciousness at the heart of the puzzle of reality. Everything you know, everything you remember, and everything you believe rests on the existence of this inner light that allows experience to happen. When you look at a tree, the tree does not simply appear. Consciousness receives the signals from your eyes, shapes them into a meaningful image, and allows you to feel that you are seeing something real. When you hear a piece of music, the notes do not just arrive. Consciousness interprets them, connects them to emotion, and gives the experience its depth. In a sense, consciousness is the container in which reality appears. It is not separate from the world, but it is not identical to the world either. It is the space where perception and meaning come together. This raises an intriguing question about what consciousness contributes to the sense of reality. The physical world exists with, or without, observation, but your personal world, the one you actually move through, is shaped entirely by experience. Without consciousness, colours would be wavelengths, sounds would be vibrations, and tastes would be chemical reactions. Only when these signals reach awareness do they become the rich sensations that make life feel alive. Consciousness transforms raw information into lived experience. Subjective experience complicates any attempt to define what is real, because it varies so greatly between individuals. Two people can look at the same landscape and feel entirely different emotions. One might feel calm while the other remembers something bittersweet. The sight is the same, but the meaning is different because consciousness adds interpretation. What feels overwhelmingly real to one person may feel distant to another. This variation does not make reality any less real, but it shows how strongly consciousness shapes the version of reality each person inhabits. Trying to understand consciousness without slipping into metaphysical speculation is difficult, but exploring awareness gently can reveal how central it is to the experience of being alive. At the simplest level, consciousness is what allows you to know that you are experiencing something. Without it, sensations would still occur, but there would be no awareness of them. A thought would simply be electrical activity. A feeling would be a chemical shift. Consciousness turns these processes into something felt. Scientists and philosophers have debated what consciousness actually is for centuries. Some suggest it arises from the combined activity of billions of neurons, each contributing a small part to the overall experience. Others propose that consciousness emerges when information in the brain becomes integrated in a certain way. Still others wonder whether consciousness might be a fundamental feature of the universe, something that matter can express when arranged in complex patterns. These ideas remain open, not because the question is impossible, but because it touches on something that science has only recently been able to study directly. Even without a full explanation, consciousness can be explored through its qualities. One of its most striking features is its unity. No matter how many thoughts or sensations arise in a moment, consciousness presents them as part of a single experience. You can hear a sound, feel the temperature of the room, remember something from earlier in the day, and still recognize all of it as happening to you. This unity is remarkable when you consider that the brain processes information in many different areas. Consciousness brings these pieces together effortlessly. Another feature is its continuity. Even when the contents of consciousness change from moment to moment, there is a sense of ongoing awareness. This continuity helps create the feeling of a stable self, even though, as explored earlier, the self is anything but stable. Consciousness provides the backdrop on which the narrative of identity is projected. It does not create the story, but it hosts it. Perhaps the most enigmatic quality of consciousness is its ability to reflect on itself. The fact that you can be aware of being aware sets consciousness apart from other biological functions. Your heart never wonders about its heartbeat. Your stomach never contemplates digestion. But consciousness can examine its own nature, question its own origin, and explore its own boundaries. This reflective capacity is what allows humans to ask questions about reality, meaning, and existence. In considering consciousness as part of the puzzle of reality, it becomes clear that the world you experience cannot be separated from the awareness that experiences it. A landscape without consciousness is simply terrain. A sound without consciousness is just vibration. A moment without consciousness is only an event. Consciousness is what gives these things their presence in your life. This does not mean that consciousness creates the physical world, nor does it imply that reality depends entirely on the observer. Instead, it shows that the observer contributes something essential to the experience of reality. Without consciousness, the universe would contain information but no experience. With consciousness, information becomes sensation, thought, emotion, memory, and meaning. Consciousness is not the whole of reality, but it is the way reality becomes real to the individual. There is a gentle beauty in thinking of consciousness as the quiet light inside the illusion. It does not change the world itself, but it illuminates your part of it. It allows the brain's constructions, perceptions, memories, interpretations to become part of a lived experience, even if reality includes illusions, approximations, or interpretations. Consciousness gives those things weight and immediacy. It lets you feel the world rather than simply register it. Consciousness is also what allows wonder to exist. Without awareness, the universe might be impressive, but it could not be appreciated. The sound of rain, the colour of a sunset, the warmth of a hand, the rhythm of breath, all of these become meaningful only because consciousness receives them. It provides the grounding for joy, curiosity, compassion, and reflection. Despite being central to experience, consciousness remains one of the least understood phenomena in science. Yet this uncertainty does not diminish its importance. It adds to the sense of mystery that surrounds the experience of being alive. Consciousness does not need to be fully explained for it to be appreciated. Its presence is enough. In the end, consciousness is both ordinary and extraordinary. It is the background for every moment and the spark that makes those moments feel significant. It is the silent observer that does not interfere yet shapes everything. And in exploring what it means to be conscious, you glimpse something essential about the nature of reality, not what exists outside, but what it feels like to exist within. There's a quiet comfort in believing that reality is something we can fully understand, as though the world were a puzzle waiting for the right set of answers. But human beings move through life with senses that capture only a thin fraction of what exists, and with minds shaped by evolution to prioritize survival rather than perfect comprehension. Even the most advanced scientific tools extend perception only so far. Beyond that boundary lies a wide expanse of unknowns, reminders that our version of reality may be just one narrow slice of something much larger. The limits begin with the senses. Humans see a narrow band of light, hear only a small range of vibrations, and smell far fewer chemical signals than many animals. What feels like a complete picture of the world is actually a filtered glimpse. Bees see ultraviolet patterns on flowers that are invisible to us. Some birds perceive magnetic fields. Whales hear frequencies that travel thousands of miles through the ocean. Each creature lives in a world shaped by its sensory abilities, and humans are no different. Reality feels complete only because the brain fills in the blanks. Cognition has boundaries as well. The brain is extraordinary, but it relies on shortcuts, assumptions, and approximations to make sense of the environment. It simplifies information, groups things into patterns, and relies on past experience to interpret the present. These strategies allow humans to function efficiently, but they also ensure that perception will never be perfect. The world is too detailed, too complex, and too dynamic for any mind to grasp in full. Science has been a powerful way to extend these boundaries, giving access to worlds that were once invisible. Telescopes reveal galaxies so distant that their light left them long before humans existed. Microscopes unveil structures smaller than any sense could detect. Particle detectors probe realms where intuition fails completely. And yet, even with all this progress, each discovery seems to reveal more unanswered questions. Every layer of understanding uncovers another layer beneath it, like peeling an onion with no clear center. This ongoing uncertainty is not a failure of science. It is a sign of scientific humility, a reminder that knowledge grows by acknowledging its limits. The most profound scientific breakthroughs often begin with the recognition that something does not fit with existing theories. Rather than viewing uncertainty as a problem, science treats it as an invitation to explore. The mysteries of dark matter, dark energy, consciousness, and the origins of the universe remain open not because science is incomplete, but because the universe is vast enough to surpass even the most powerful models. These limits also offer a gentle reminder that human reality is shaped by perspective. If senses could expand or cognition could shift, the world might appear completely different. Imagine being able to see radio waves or feel gravitational fields. Picture hearing the hum of atoms or perceiving the slow drift of continents. These phenomena are part of the universe, yet they remain unnoticed because humans are not built to detect them. Our slice of reality is shaped by what we can perceive, and what we can perceive is shaped by biology. There is something deeply peaceful in recognizing that reality may extend far beyond what is accessible. Instead of being overwhelming, this awareness can be grounding. It suggests that mystery is not an obstacle but a companion. It means there will always be more to learn, more to uncover, and more to imagine. It means the universe holds secrets not because it is hiding them, but because our perspective is limited. Some scientists and philosophers propose that the world as humans experience it exists on only one layer of reality, much like a page in an immense book. Other layers might exist alongside or beyond our own, governed by rules that are unfamiliar or inaccessible. These ideas are not claims but reflections on how strange the universe becomes when examined closely. They remind us that what we call reality is shaped alike by what we can detect and by what we cannot. The thought that reality may be larger than what we experience should not diminish the meaning of everyday life. If anything, it adds richness to it. The smallness of our perspective highlights the beauty of what we can know. A sunrise may be only a local event on a distant planet, yet it feels magnificent because consciousness allows it to be witnessed. A quiet conversation, a shared laugh, a moment of understanding. These experiences gain value not because they reveal the whole universe, but because they illuminate one person's corner of it. The limits of knowing also encourage humility in how we discuss truth. It is easy to assume that what we see is all there is, or that what we believe is fully accurate. But recognizing cognitive and sensory boundaries opens the door to curiosity. It allows space for new information, new interpretations, and new perspectives. It softens certainty in favor of exploration. And exploration is where wonder begins. There is gentle humor in realizing how confidently humans navigate a world they only partly understand. People make plans for the future in a universe filled with unknowns. They build technologies based on theories that may someday be replaced. They debate the nature of time and space while living inside a cosmic system that remains largely mysterious. Yet this confidence is not misplaced. It is part of what drives progress. Humans learn by reaching beyond their limits, even when those limits shift with each discovery. The idea that our reality might be just a thin slice of something larger does not mean the slice is shallow or insignificant. It means it is part of a greater whole. It suggests that the universe is both comprehensible and incomprehensible, both familiar and unfathomable. It means that reality is layered, structured, and endlessly deep. In the quiet moments of contemplation, it can be calming to remember that it is not necessary to understand everything to find meaning. The limits of knowing do not diminish the experience of being alive. They enhance it, turning the universe into a vast landscape of possibility rather than a closed book. There will always be more questions than answers, more mysteries than explanations, and that is part of the beauty of reality. You exist within a world that is both accessible and unreachable, both illuminated and shadowed, both known and unknown. Understanding the limits of knowing creates space for wonder, and in that wonder, reality becomes even more intriguing. Reality might begin with perception, but it grows into something far larger when people start comparing their experiences. Once humans began talking to each other, describing what they saw, felt, and remembered, a shared world began to form. This shared world, often called consensus reality, is not created by any single person. It emerges from countless conversations, agreements, observations, and quiet assumptions. It is the version of reality that societies rely on to function, the common ground that allows people to navigate life together even while their private perceptions differ in subtle ways. At its heart, consensus reality is built on the simple act of agreeing on what things mean. When people point to the same patch of sky and call it blue, they are not proving that the colour truly exists in an objective sense. They are agreeing on a label that helps them communicate. One person might see a slightly different shade from another, but the word bridges that gap. If the sky were suddenly declared purple by unanimous vote, society would adjust, and the colour would still carry the same role in conversation. What matters is not the wavelength of light alone, but the shared understanding attached to it. Language plays a crucial role in this process. It stabilizes experience by giving people a common set of concepts. Without shared words, everyone would live in a private world with no way to compare notes. Imagine trying to describe a landscape without any nouns, or trying to express a feeling without verbs or adjectives. Language shapes how people carve the world into pieces. It defines categories, draws boundaries, and allows ideas to move from one mind to another. Once language exists, reality becomes something collaborative. People agree that objects have names, that numbers describe quantities, that days follow one another in a predictable order. They agree on rules, measurements, and meanings. These agreements form the backbone of culture, law, science, and daily life. Even simple interactions rely on them. When someone says they are cold, others know what that means because they share a framework for temperature and sensation, even though each person's experience is unique. Science adds another layer of stability to this shared world. While language helps people describe their perceptions, science provides methods for testing and verifying them. Instead of relying solely on personal interpretation, science uses measurement, repetition, and comparison. If two people argue about whether water boils at a certain temperature, they can test it using the same procedure. If many people repeat the experiment and get consistent results, society incorporates that result into its shared understanding. This does not make science infallible, but it does make it self-correcting. When new evidence appears, scientific consensus shifts, and with it, society's understanding of reality evolves. In this way, science becomes a tool for aligning subjective worlds with something more universal. It helps reduce disagreement by offering reliable ways to describe and predict the world. Consensus reality also includes social norms, rituals, and common beliefs. People may agree that shaking hands is a polite greeting, or that red traffic lights mean stop. These elements are not physical facts, yet they shape behaviour as powerfully as physical laws. They exist because people believe in them collectively. If the agreement changes, the reality changes with it. This shows how flexible the shared world can be, adapting as societies evolve. There is gentle humour in how easily humans accept certain shared beliefs without questioning them. For example, most people agree that a minute contains 60 seconds, not because the universe demands it, but because humans decided it long ago. They agree that north is upward on maps, even though maps could just as easily be drawn another way. They agree that a calendar begins in January, even though different cultures have begun the year in spring, in autumn, or whenever the harvest cycles told them to. These agreements are not mistakes. They're tools that allow societies to coordinate. Consensus also shapes more subtle aspects of experience. People agree on what counts as success, beauty, kindness, or fairness. These ideas vary across cultures, but within each community, they form a shared reality that influences how individuals think and behave. Someone raised in a society that values modesty may see confidence differently from someone raised in a society that values ambition. The physical world has not changed, but the shared meaning attached to it has. This highlights a gentle truth. Consensus reality is not a perfect reflection of the universe. It is a collaborative approximation, built from communication and shaped by culture. It is strong enough to support cities, laws, sciences, and relationships, yet flexible enough to change when societies reconsider their values. It is both sturdy and fluid, a balance that allows humans to live together without needing identical perceptions. One of the most remarkable aspects of consensus reality is how naturally humans participate in it. Children learn shared meanings simply by listening and observing. They absorb the local worldview without needing explicit instruction. By the time they grow older, they move through society using the same conceptual tools as everyone around them. This is why people raised in different cultures sometimes see the same event in different ways, not because reality differs between them, but because their shared frameworks differ. Despite these differences, consensus reality provides more unity than division. It allows strangers to work together, understand each other's intentions, and coordinate their actions. A doctor in one country can collaborate with scientists from another because they use the same shared language of biology and medicine. A person can travel to a distant city and still recognize the meaning of traffic signs, airport symbols, and basic gestures. Consensus creates continuity across time and space. There is a gentle elegance in recognizing that reality is not only something experienced individually, but something shaped collectively. The physical world provides the foundation, but society builds the structure that sits on top of it. Consensus does not replace reality. It helps interpret it, giving meaning to the raw sensations of life. Understanding consensus reality can also cultivate empathy. If someone else sees a situation differently, it may be because they are operating within a slightly different version of the shared world. Their experiences, culture, and language shape their interpretation. Recognizing this fosters patience and curiosity rather than conflict. In the end, consensus reality is a shared effort, a tapestry woven from words, beliefs, practices, and scientific principles. It is the world that people agree on, so they can live cooperatively. It may not capture every aspect of the universe, but it offers enough stability for societies to grow, for ideas to spread, and for individuals to find their place within a larger whole. It is the world you wake up to each day, shaped by countless voices and countless minds, each adding a thread to the shared fabric of what is real. When you glance at the world around you, it is easy to imagine that reality springs into clarity the moment you look at it. A tree becomes a tree when you see it. A sound becomes a sound when you hear it. A breeze becomes a breeze when you feel it. But physics offers a quieter, more impartial perspective. The universe does not wait for attention. It does not flicker into being when someone opens their eyes. It continues on its own terms, steady and unhurried, whether or not any observer is present. Classical physics paints this picture most clearly. In that framework, every object follows predictable laws, every motion has a cause, and every cause leads to an effect. If you know the position and speed of something, you can predict what it will do next. A planet moves through space whether or not anyone watches it. A stone rolls down a hill even if no one stands nearby to see it. The world, in classical thinking, is a grand unfolding of perfectly consistent behaviour. Observation is a convenient way to witness the patterns, but it does not influence them. This view can be surprisingly comforting. It suggests that reality is stable and trustworthy, and that the universe behaves the same way in the most remote corners as it does in familiar surroundings. Stars form, galaxies collide, and winds sweep across distant planets with no need for an audience. Even before life emerged on Earth, the universe had already spent billions of years growing, cooling, expanding, and refining its structure. Everything that exists now is part of that ongoing story, a story that began long before any observer arrived to appreciate it. Quantum physics, however, adds a different flavour to this picture. At very small scales, the universe becomes less predictable. Particles do not always behave like tiny objects following precise paths. Instead, they exist in patterns of possibility. They drift through uncertainty, taking on more definite properties only when measured. This behaviour has led to the famous idea that observation affects quantum systems. It can sound, at first, as though the universe needs to be looked at in order to behave properly. But the word observation in this context is misleading. In quantum physics, an observation is not a conscious act, it is an interaction. When a particle meets another particle, or when light bounces off an object, the event counts as a measurement. These interactions happen constantly, everywhere, all the time. Particles collide, fields fluctuate, and energies shift long before any conscious observer enters the scene. The unpredictability of quantum events is not tied to human attention. It is simply the way nature behaves at microscopic scales. This means that quantum physics, rather than making reality dependent on human observation, simply reveals a world that does not follow classical certainty. The universe is not waiting for someone to check on it. It is carrying on with a set of rules that include both unpredictability and structure, both possibility and limitation. Some processes unfold with crisp precision. Others unfold within a range of outcomes. Many interactions are accompanied by uncertainty, yet the larger patterns they create remain stable. A star still burns even when no one sees it. A wave still breaks on a quiet beach even when the shoreline is empty. A forest still grows in a remote valley even if no creature walks beneath the trees. These events involve countless quantum interactions, but none of them need a witness. Physics describes how processes occur, not whether someone is present to notice them. There is something peaceful in accepting that the universe continues on its own, indifferent to observation. The world is full of events that no one will ever see. Deep ocean currents flow for centuries without interruption. Clouds form and disperse on uninhabited worlds. Particles born in distant stars travel across unimaginable distances, passing silently through empty space. Existence does not require an audience, and reality does not depend on awareness to unfold. This perspective also highlights the beauty of physical laws. They describe relationships between things, not relationships between things and observers. Gravity binds objects together regardless of whether anyone is watching. Electromagnetic forces shape atoms, molecules, and light without ever needing attention. Nuclear reactions fuel stars with the same intensity, whether witnessed by eyes, telescopes, or nothing at all. Even time itself progresses independently. A second passes whether counted or ignored. A moment arrives whether observed or missed. The universe carries on with quiet consistency, allowing life to find its place within a much larger framework. Understanding that reality exists beyond observation can also soften the boundary between the known and the unknown. Humans tend to think of unobserved events as mysterious or incomplete, but in truth they are simply part of the universe's natural flow. Not seeing something does not make it less real. Not measuring a process does not halt it. The world is larger than perception, and most of reality unfolds beyond the limits of human awareness. This idea may feel humbling, but it can also be grounding. It means that existence does not rely on attention or comprehension. The universe is not fragile or uncertain. It is robust, dynamic, and incredibly patient. It provides the stage on which conscious observers eventually appear, but it does not require them to perform. There is gentle humour in imagining the universe waiting expectantly for someone to look at it, as though galaxies might postpone merging until an audience is ready. But of course, the cosmos is far too busy for that. It moves at its own pace, guided by its own laws, unconcerned with whether anyone happens to notice. Even in the realm of human experience, unobserved events remain real. A tree falling in a forest does make a sound, because sound is a physical process, not a psychological one. Waves spread through air whether or not anyone hears them. Light scatters across surfaces even if no eyes receive it. Reality is not created by observation, it is only revealed by it. Reflecting on this offers a calm sense of continuity. The universe existed before you, and it will continue after you. It is vast enough to hold countless moments that no one will ever witness. Yet you are part of that vastness, an observer who briefly experiences a small fragment of a much larger existence. Your awareness is a gift, not a requirement for the world to be real. Physics without observers tells a simple, elegant story. The universe does not depend on attention. It unfolds with or without witnesses, guided by laws that operate everywhere and every moment. And within that quiet, ongoing unfolding lies one of the most beautiful aspects of existence. That reality is generous enough to allow consciousness to emerge, even though it never needed it. You're here to see the universe, but the universe does not need to be seen to be. Reality often feels like something that should fall neatly into one category or another. Either the world is exactly as it appears, solid and dependable, or it is an elaborate illusion crafted by the brain. Either we discover truth by looking outward, or we invent it by looking inward. But as you move through the ideas explored so far, a softer, more interesting possibility emerges. Reality may not be entirely discovered, nor entirely constructed. It may sit in a quiet middle ground where perception, physics, consciousness, and interpretation meet, each contributing its own piece to the experience of being alive. This middle ground is not a place of confusion, it is a place of balance, where seemingly opposite ideas can coexist without cancelling each other out. The physical world exists independently, following its own rules whether or not anyone is watching. Yet the world you personally move through is shaped by the brain, which interprets sensory signals, adds expectations, and stitches everything into a coherent experience. You're not inventing reality out of nothing, but you're not absorbing it perfectly either. Your experience is a meeting point between what the universe is doing and what your mind makes of it. In this sense, illusion does not mean falsehood, it means complexity. When the brain fills in gaps or smooths out details, It does so to create a workable version of the world. The illusion is not a deception, but an adaptation. A colour is not a property of the universe alone. It is the product of light interacting with the eye and being interpreted by the brain. A sound is not merely vibration. It becomes meaningful only when awareness shapes it. Illusions reveal the mechanics behind these processes, showing how perception is a mixture of discovery and construction. This mixture does not make reality fragile. Instead, it makes it richer. The physical laws beneath everything are precise and dependable. Gravity holds planets in orbit whether or not anyone understands it. Atoms form molecules through consistent patterns. Stars burn because of processes that have been unfolding since long before Earth existed. These aspects of reality are discovered, not invented. Yet the way humans experience these truths depends on perspective, language, culture, and personal interpretation. Reality itself does not change, but the doorway through which you encounter it does. Science quietly embraces this duality. Scientists accept that theories are models, approximations that capture aspects of reality, without claiming to represent the whole of it. A scientific theory is trusted not because it is perfect, but because it works reliably within its domain. Newton's laws describe motion beautifully at everyday scales, even though modern physics reveals deeper layers beneath them. Quantum mechanics, for all its strangeness, predicts experimental results with astonishing accuracy, even though its interpretation remains open to debate. Science does not demand certainty. It asks only for consistency, testability, and a willingness to revise understanding when new information arrives. This humility does not weaken science, it strengthens it. By acknowledging uncertainty, science remains flexible, open to discovery, and able to refine its view of reality over time. It reflects the understanding that reality is larger than any single theory can describe. At the same time, the accuracy of scientific predictions gives confidence that we are not wandering blindly. The models may be incomplete, but they're not imaginary. They reveal genuine patterns woven into the structure of the universe. This attitude mirrors the quiet middle ground in everyday life. People rely on perceptions that are partly shaped by the senses and partly by interpretation. These perceptions may not be perfect, but they are functional. They allow humans to navigate the world, connect with one another, form memories, and build meaning. The fact that perception is not absolute does not make it untrustworthy. It simply means that reality must be held gently, recognizing both what is stable and what is flexible. Holding paradox lightly becomes a kind of skill. It allows you to appreciate that two things can be true at the same time. Reality can exist independently while also being experienced subjectively. The universe can follow precise laws while also containing uncertainty at small scales. Consciousness can feel deeply personal while emerging from biological processes shared across life. Illusions can reveal the limitations of perception, while also showing how impressively the brain constructs the world. Imagining this balance can feel like holding a delicate object in the palm of your hand. You do not grip it tightly, nor do you let it fall. You simply let it rest there, appreciating its shape without demanding that it be simple. The same gentle approach can be applied to understanding reality. It does not need to be fully grasped to be meaningful. It does not need to fit into a single category to be trusted. It can be partly known, partly mysterious, and still entirely worth exploring. There is also a soft beauty in realizing that this middle ground allows for wonder. If everything were perfectly certain, the world would feel narrow. If everything were illusion, the world would feel empty. But between these extremes lies a landscape where discovery is still possible, where perception still surprises, and where understanding can grow without ever reaching its final form. This uncertainty is not something to fear. It is what keeps curiosity alive. The experience of reality becomes richer when you recognize that your senses, your mind, and the physical world are all participating together. You're not a passive observer receiving a finished product, nor are you the creator of everything you see. You are part of the process, shaped by the world, while also shaping your interpretation of it. This partnership between external truth and internal construction is what makes experience feel textured and alive. It is the reason why two people can look at the same night sky and feel different things, yet still agree that the stars are there. It is why science can make precise predictions while leaving space for mystery. It is why the world feels both familiar and surprising, both stable and fluid. In this quiet middle ground, reality does not need to be reduced to a single definition. It can be many things at once, layered, dynamic, and open to interpretation. It can be discovered through science, experienced through consciousness, shaped through perception, and shared through language. Illusion and certainty do not sit at opposite ends of a spectrum. They intertwine, creating a world that is both comprehensible and endlessly intriguing. Holding this paradox gently allows you to move through life with a sense of clarity and openness. Reality becomes something to engage with, not something to conquer. Understanding becomes a journey rather than a destination. And the world, with all its layers and complexities, becomes a place where wonder and knowledge can coexist peacefully. When you set aside theories, measurements, and philosophical puzzles, what remains is the simple, immediate experience of being alive. The feeling of breath moving in and out, the warmth of your hands, the softness of a familiar voice, the quiet hum of awareness behind every moment. This lived experience is where reality becomes personal. It is where the abstract ideas about perception, consciousness, physics, and illusion meet the grounded sense of simply existing. No matter how strange the deeper layers of reality may be, the feeling of being here is undeniable. This felt experience is often taken for granted. It unfolds quietly in the background while attention drifts to tasks, worries, conversations, and plans, yet it is the foundation of everything. Before deciding whether reality is constructed or discovered, before questioning the nature of matter or time, before comparing subjective worlds with objective ones, there is the simple fact that you are aware. This awareness does not answer the big questions, but it supports them. It is the home from which curiosity steps out into the unknown. The feeling of reality is shaped by meaning as much as by physics. The universe could be vast, ancient, and governed by precise laws, but without meaning, those facts would feel cold and distant. Meaning gives reality its colour, its texture, its emotional weight. It anchors you in a world that is not just seen but felt. It shapes why you care about certain moments, why you remember certain experiences, and why some things feel more real than others. Meaning does not depend on discovering the ultimate nature of the universe. It emerges from connection, experience, and reflection. A sunset feels real not because you have measured its wavelengths, but because its colours stir something inside you. A conversation feels real because it creates understanding. A memory feels real because it holds emotional resonance. These aspects of reality are not illusions. They are part of what it means to live within a conscious mind. This does not diminish the physical world. It enhances it. Physics describes how stars burn, how atoms bond, how gravity shapes space. These explanations provide structure and clarity. But the sense of reality arises from the intersection between these explanations and your inner experience. You live at the meeting point between external forces and internal meaning. Without awareness, the universe would carry on silently. With awareness, even small moments gain significance. When people wonder whether reality is an illusion, they often imagine something fragile, as though discovering deeper layers might cause the world to dissolve. But illusions in perception do not make chairs vanish or mountains disappear. They reveal how interpretation colours experience. The world does not become less real because the brain participates in constructing it. It becomes more interesting. It becomes a partnership between what exists outside and what arises within. Even the strangest aspects of physics do not threaten the feeling of reality. Quantum unpredictability does not disrupt the solidity of daily life. The flexibility of space and time does not make your surroundings any less steady. The layered nature of emergence does not make the world less meaningful. These ideas simply show that the universe contains more depth than intuition alone can reach. Reality can be both mysterious and dependable, both surprising and familiar, and in the midst of all this complexity, the feeling of realness comes from moments that are often small. The quiet stillness of early morning, the sound of rain against a window, the laughter that catches you off guard, the way a memory returns unexpectedly, carrying warmth or longing. These experiences do not require a full explanation to matter. They anchor you, gently reminding you that being alive is more than understanding mechanisms. It is also about experiencing moments fully. Meaning can come from curiosity as well. The very act of wondering about reality connects you to something larger. Asking what is real does not distance you from life. It deepens engagement. It shows that the mind is awake, attentive, and willing to explore. Curiosity is a form of appreciation. It turns the world into a space where discovery is always possible, even in familiar surroundings. There is soft reassurance in recognizing that reality does not need to be simple or certain to feel real. It does not need to be fully understood to be lived meaningfully. The layers beneath perception, the uncertainties in physics, the mysteries of consciousness. These do not erase the solidity of your experience. They enrich it. They invite a slower, more contemplative way of looking at the world. The shared reality built through language, science, and culture provides stability. The personal reality shaped by perception and emotion provides texture. The deeper reality described by physics provides structure. Together they create a world that is both external and internal, both objective and subjective. None of these layers negates the others. They coexist, forming a tapestry of meaning, sensation, and pattern. Reality feels real not because it is simple, but because it is lived. Because you move through it, respond to it, shape it, and are shaped by it. The truth of experience does not depend on solving every question. It rests on engagement, connection, and awareness. Even if the universe is layered or strange, even if perception adds its own colours and contours, even if consciousness participates in shaping your world, the reality you live is still your reality. It has weight, presence, and depth. It carries you through each day and invites you to explore what it means to exist. As this journey through the nature of reality approaches its final stretch, the path becomes quieter. Less about possibilities and more about presence. Less about theories and more about the lived experience beneath them. The question shifts from what is reality to something softer, something closer to home. What does it mean here and now for reality to feel real? As the ideas settle, a calm picture begins to form. Reality, it seems, is not one thing. It is not purely constructed by the mind nor entirely imposed by the outside world. It is layered, filtered, interpreted, and shared. It is shaped by physics, held together by perception, enriched by meaning, and softened by consciousness. Even when the deeper layers grow strange, even when certainty dissolves into probability or perspective, the experience of living within reality remains steady and deeply familiar. Illusion and truth, rather than competing, weave together to create the world you know. The brain fills in gaps not to deceive you, but to help you move gracefully through each day. Science reveals mysteries not to unsettle you, but to show that the universe is larger and more intricate than instinct suggests. Subjective moments and objective patterns coexist, each offering a different kind of insight. The world may be partly constructed, yet it is also discovered, partly interpreted, yet also shared, partly uncertain, yet still completely livable. There is reassurance in this balance. You do not need perfect knowledge to feel grounded. You do not need full clarity to find meaning. Reality may include illusions, interpretations, and hidden depths, but none of this makes it any less real. You live within a world that holds you gently, offering sensations, relationships, memories, and moments that feel authentic because they are experienced directly. The richness of reality comes not from certainty, but from participation. Even if perception shapes what you see, the experiences you gather are still yours. Even if consciousness colours the world, the colours remain beautiful. And even if the universe contains mysteries far beyond current understanding, you still wake each day into a world that supports you, surrounds you, and invites wonder. So the question lingers softly at the edge of thought, not demanding an answer, but opening a doorway to reflection. What does it mean if reality is partly constructed? What does it mean if it is stranger than intuition ever imagined? What does it mean if illusion and truth sit side by side, each adding something to the experience of being alive? Perhaps it means that reality, whatever its deepest nature may be, is still a place where meaning grows, where curiosity thrives, and where awareness finds a home.